Hi everyone, welcome to video 2. So now you should be on page 3 of your worksheet. So page 3 is going to talk more about oxidation and reduction. What are these things? So in balancing what's called redox reactions, we're trying to get to the point where we understand how to conserve a charge across a reaction. And in doing that, we first have to use what we learned about assigning oxidation states, and then we need to figure out which species in a reaction is reduced and which one is oxidized. So in doing this, reduction is the fancy word that means gain of electrons, or reduction in charge, or reduction in oxidation state. So the idea is whatever species in a chemical reaction has a decrease in oxidation states from being a reactant to becoming a product, it was considered reduced. And whatever species has an increase in oxidation state, or whichever species loses electrons, that's going to be considered the species that was oxidized. Now you can also have another word for this. If the species was reduced, then it is also called the oxidizing agent. Okay? If it was oxidized, then it's also called the reducing agent. I typically do not use these latter words. I almost always refer to species being reduced or oxidized, but I wanted you to know that they're also synonymous with the idea of that species being the oxidizing agent and the reducing agent. And in referring to this, we're always talking about reactants. So that reactant is the oxidizing agent. It was reduced. Okay, so those words go together. Alright, so on here we're going to do our first chemical reaction. We're going to try and figure out which species was reduced and which species is oxidized. So when looking at these, and once again, there's also on there a couple mnemonic devices that I've heard from students, Leoger or oil rig. If those help you remember which one oxidized or was reduced, which one means which, awesome. But if they don't, ignore them. I just always remember oxidation, loss of electrons, reduction, increase of electrons. Okay, gain of electrons. Whatever you do, works for me. Okay, so what we're going to do is we're going to do almost like we're balancing the atoms, but we're going to balance the charge. So I'm going to write each species down the middle. So I have each of my atoms down the middle. Now I want to write what is my charge on both sides of the equation. Meaning, if I look on the left side, calcium, what is the oxidation state of this species? You should be thinking it's 0 because there's nothing written up here. So it is 0 over here. What is hydrogen? Hydrogen, remember, in water, oxygen gets to be -2, hydrogen gets to be +1. Uncross those charges. So +1, -2. Then what about over here? Calcium. Let's uncross the charges. You might think it's -1 and +1, but that's not true because oxygen is always -2. So calcium has to be +2 in order to cancel out with the oxygen. So calcium is now +2 as a product. Oxygen, -2, just like always. Hydrogen now, if it is all by itself and it's neutral, what oxidation state does hydrogen have to be? If you said +1, you're completely wrong because it should be 0. Because if it's all by itself, it makes no sense for one of these hydrogens to be +1 and one to be -1. They both have to be the same thing inside of this species for our case, and so one's 0, the other one's 0 as well. So when we look at this, we can ask ourselves first, which one did not change its oxidation state? Oxygen, it started out at -2 and it went to -2 as well. So it stayed constant throughout the reaction, which means it's neither the reducing agent nor the oxidizing agent. It wasn't reduced and it wasn't oxidized. Okay? So now we've got these two to consider. Which species is, let's look, the first one we asked for is oxidized. Okay, so oxidized means increase in oxidation number. So which of these two increased its number from the reactants to the products? Calcium. Okay, so this is my oxidate. This one was oxidized. Okay, ran out of room. Calcium went from 0 to +2, so it increased its oxidation state, which is the definition of it being oxidized. Hydrogen was reduced in oxidation state, so it went from +1 to 0, and they always are in pairs. If one species is decreased, the other species is increased. That's why it's called sometimes redox reactions or a redox pair, because you can't just pull electrons out of nowhere, you have to get them from somewhere. So where did hydrogen get their electrons from when it went from +1 to 0? It stole them from calcium. So calcium gave up 2 at the same time as each hydrogen picked up 1. Okay? So hydrogen is reduced. Number 12 on your worksheet is this number. So 2 hydrogens plus an oxygen yields 2 waters. So we have already balanced this reaction multiple times in lecture, but we've never looked at it as an electrochemical reaction, which it is. It's very much electrochemical. So let's once again figure out which species was oxidized and which was reduced in this. So we've got hydrogen and oxygen. Over here, it's diatomic, it's a neutral molecule, so it's going to be 0. Same thing here, oxygen, it's all by itself, and there's nothing written up here, so it has to be 0. But over here, now they're together, so it's more of an ionic complex. So you've got oxygen gets to be -2, hydrogen gets to be +1. So now that I've identified the oxidation states of hydrogen as a reactant and as a product, I can go through and figure out whether it was reduced or whether it was oxidized. So in this case, oxygen went from 0 to +1. It increased oxidation state, so it was oxidized. Oxygen, on the other hand, went from 0 to -2, so its oxidation state was reduced, so it was reduced. The last equation has copper and silver. So over here, once again, try and figure out what is the state of each atom. So over on the left, it's 0. For silver, it's +1. Over here, copper goes to 2+, silver goes to 0. So once again, you had to know how to identify those oxidation states in order to answer the question of, in this chemical reaction, which species was oxidized, which one was reduced. So in this case, go through, figure out which of these two it should be, and then do that last problem, number 14, on your own. Then watch video number 3.